Hey everyone, Brad Pitt here, and thanks for watching. So today I will be the guest speaker, all right, for your eighth grade class today. And did you know that Mr. Ring and I go way back to high school, even though you know he's probably a little bit younger than me? Yeah, you didn't think so, did you? All right. So what we're gonna do today is look at two special cases when we're factoring polynomials. And in some ways, it's almost as if we're taking half a step back, but I wanted to show you those two things and see what they look like. Okay, so let's go.
All right, so today what we're gonna do is talk about special cases factoring, okay? And there are two special cases and they're both equally really simple. So it is really my hope to keep it short because yesterday I gave you another 30-minute video, which I feel really bad about. So if I could keep it at 10, I would be ecstatic, all right? No promises though. All right, now, so the first thing you gotta note, all right, is what we call special cases factoring. And the first one is called a perfect square factoring, okay? So you should probably write this down in your notebook if you're watching this right now. So, okay, the first case, right, perfect squares factoring. What exactly does that mean, right? The question goes something like this. In these three examples, they all qualify, all right, as a perfect square factoring. So what does that mean, right? The question is something like this. What two exact same expressions will give you this when you multiply it using FOIL? So I'll write it out what I mean, right? So in other words, when you see these sort of questions, right, these quadratic functions, what you will realize eventually is that whatever your factors are, they're always going to be the exact same factors. So no different than, like, for example, like 2 times 2, that's 4, or 3 times 3, that's 9, so on and so forth, right? Same thing here. So the question is something like this, right? What times what will give you x squared minus xx plus 9, right? Now, knowing that, I know that 3 times 3 is 9, and that 3 plus 3 is 6, right? And that since this is a positive, that means I have to have two numbers that multiply to give me a positive, but when I add them, it has to be a negative. So what's the only possibility here, right? If they're both negative, right? And that's it, done. That's all. That's the lesson today. All right. Now, real quick, what do you think are the two factors to make it so that when you multiply it, you will get this quadratic function? Yeah, x minus 10, right? And remember, right? If this second operation is plus and the middle one is a negative, right? You can bet that both expressions in the answer is going to be negative, right? Because only negative times a negative can give you a positive, but when you add two negative numbers, it's still negative, right? All right, one last one, and then we're done, and then we're going to move on to the second case. Now, here, right, again, what must be the two numbers? What two of the numbers that are the same, right? What two of the same numbers multiply to 36 positive, but when you add them gives you negative 12, right? That's 6, right? As a matter of fact, negative 6, right? And you can check your answers. You could do x times x, right? And then first, outside, inside, and last, right? And you FOIL it, you will get this as an answer. Okay? All right? Good? All right. Now, I want you to practice, so you know what? Yeah, you can practice. Hold on. When you come back, I'll show you the answer key. Okay? So press pause right now. All right, and we're back. All right, so these are the answers. Now, I didn't realize that there are more questions down here. Oh, hold on, let me give you a moment to at least try to check your answers, okay? Press pause, check your answers. I want to show you a couple of slightly more different questions, all right? So let's look down here. Now, don't get intimidated, because I know what you're thinking, because the part of the intimidation, all right, factor of these kind of questions is that the leading coefficients here are not 1 anymore. But, you know, it's not like you haven't had practice before, right? And not only that, remember what I said about today's topic especially, right? both expressions are the same. So that means that has to be 2x, right? Because you're not going to do 4x times x, right? And then, right, how do you get 9? 3 and 3, right? And then since they're both positive, they both have to be positive. Now, let's see if we're right. I'll use my magic pen first, right? That's 4x squared. Outside, that's 6x. Inside, 6x. And then last, plus 9. Look, 4x squared plus 12x plus 9. All right? So that's it. Okay? That's how you do that. All right? Now, with that said, I'm not sure why I gave you that last one, actually. Oh, I know. No, that's not true. Yeah, we don't need to do this one. That's not a perfect square. Yeah, I don't even know why I put that there. All right? So with that said, try these two right now. Okay? And then when you come back, I will show you the answer. Okay? So press pause right now. All right, and here we go. All right, so these are my 3 answers. Now, I know what some of you might be thinking, all right, even if not outright saying it out loud, and that is, hey, Mr. English, I mean, how am I supposed to know when I, like, you know, if I see a question like this on a test somewhere, right, how am I supposed to know that's perfect square and then I could proceed? You don't always 100% know, but the telltale sign is this, all right? If you look at, let me use my highlighters, right? The telltale sign, something like this. If that's a perfect square, and that's a perfect square, and perfect square meaning like you get 2 whole numbers, right? 2 of the same whole number as an answer, right? If you're trying to, you know, take a square root, right? 16 and 25, yeah, they're both perfect squares. 25 and 9, yeah, both perfect squares. 4 and 9, yeah, both perfect squares, right? How about this one? 1, right? Invisible 1 and 16, that's a perfect square. Invisible 1, 81, those are perfect squares. Invisible 1, 25, those are perfect squares. Invisible 1 and a visible 1, right? Those are perfect squares. Then you're probably on the right track if you can do that. Then you know, like, you know what? Let me try this perfect square method. All right? And I think that's pretty good. Now, some of you might say, do I actually have to know this? Technically, no, but we might come upon a subject soon where it would benefit you to know this, and also that it's another strategy for you to factor polynomials, okay, and helping you do it faster, okay. So it's just it's a very tiny trick in the tool bag, all right. So, all right, now what's the second special case then? It's called a difference of 2 squares factoring. So let me demonstrate. So for something like this, right, the question is, again, right, what times what will give you x squared minus 9? Now, notice how these are all binomials. I don't know if you've noticed, right? All these examples I'm giving you binomials, and that's not by accident, because think about this. If you have to rewrite this expression as a trinomial, right? Like your good old fashioned quadratic function, right? With 3 terms. You would write it like this, right? You got the x squared, you got the term in the back, right? And then now, how do you write something where you still got x, but what number, what coefficient will you have to put here where the x would actually disappear? Yeah, 0, right? So if I were to rewrite this binomial as a trinomial, this is the expression, right? Now, and that also goes to show you this. Let me get my highlighter back. What 2 numbers multiply so that when you multiply them, you get -9, but if you add those 2 numbers, you get 0. Now, think about that for a second. That's the only way that can happen, is to get 0 in the middle, is if your 2 numbers, if you add them, they become 0, right? If you add the 2 numbers, they become 0, and hence canceling out in the middle. What do you think that would have to be? Think about that. So in other words, let me pose this question to you. 3 plus what will give you 0? Yeah, -3, right? What about 100? 100 plus what will give you 0? Yeah, -100, right? Or rather, what about -50? -50 plus what gives you 0? Yeah, positive 50. So in other words, this is a little like perfect squares, except you have to have a negative here, and the middle numbers, the middle terms have to cancel. So think about what two numbers would do that. Now, first of all, it's 9, right? So it has to be 3 and 3, right? To have the same numbers, right? And not only that, you have to have the two same numbers that multiply to 9 but add up to 0. So what do you think the signs would have to be? Yeah, one has to be positive, one has to be negative. And that's it, right? And let's check the answers. Hold on. Right? X squared, right? X squared plus 3x minus 3x. Oops, that's wrong. Oops, hold on. Can I undo that? It'll undo itself. Hold on, just wait. Let me check the time. Ooh, okay. All right, maybe 15 today. All right, first, right, x squared outside minus 3x plus 3x minus 9, right? X squared plus 3x minus 3x minus 9. Look at the terms in the middle. They cancel out, right? And voila, right? We got x squared minus 9. Okay, all right, got that? Now, let's try one more together. Now, again, you might say, Mr. Englund, how is this special? Okay, my answer would be, it's another very tiny tool in the toolbox, in your bag of tricks, okay? Now, again, let's look closely here, right? We'll factor it. So, again, what two numbers, when you multiply them, give you negative 25, right? And 5, right? And that what signs would they have to be so that when you add them up, the terms cancel out in the middle, right? Positive and negative 5. That's it. Okay? All right? What about this one? Try this one on your own. What are the two factors then you would have to get? Yeah, right? X plus 7. Hold on, the light's off. Hold on, like that, okay? Now, then let's compare and contrast what the two lessons are today, okay? So let me get my magic pen. Now, here, yes, just now, the last part, have you noticed these numbers always the same, right? As a matter of fact, the whole term is the same, right? The whole expression is the same, right? Even down here with these more difficult ones, right? Same, 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 same. On the other hand, questions like this are almost the same except for the sign in the middle. Have you noticed? Right? They have opposite signs. And that's it. That's the difference between case 1 and case 2. Okay? So with that said, all right, with that said, I'm going to let you try. Hold on, I'm trying to think. What's the best way to do this? I'm trying to make it easier for you. You know what? Try, I mean, it won't take you that long to even so much as write the answer. So try this one, and this one, okay? And the last one's a little bit tough, but I think you can do it, all right? So press pause right now. Okay, now I got the answers for these two, and for this one, I want to go over it just in case you're a little hesitant, all right, about your answer. Now, the facts of the question don't change because we're still missing a term in the middle, so we can still get the difference of two squares factoring going on here. It's just that the leading coefficient is now a 4, which doesn't really deter you from doing anything because 4, remember what I just said? 4 and 25, right? They're still perfect squares, each one of these numbers, right? So here I'm going to do 2x. Here I'm going to do 2x. All right? 5 times 5 is 25. No middle term, that means the signs are the opposite. And again, right, if you want to check your answers, we can do it. All right? And I'm going to try something new for the first time. So I'm going to do first. That's 4x squared. All right, I'm just checking the answer here, by the way. First, outside, so I'm going to use my, oh man. All right, I can't, it's okay. All right, so that's what, negative 10x. Inside, that's positive 10x. And last, 5 times negative 5 is negative 25. So here we got 4x squared These cancels out, minus 25. That's it, same answer. See? All right? Now, down here, I gave myself a note that we have to get to the questions at the bottom. So I'm gonna pick and choose some of the questions here. I really like this one. I'm gonna show you how to do this one, okay? I'll show you how to do this one. I want you to try this one, and this one. All right, so let me show you this first. Now, here, you might get thrown off and say, gee, Mr. Ng, like, why is this switched around? Does it really matter? No, not really. Why? Because you just write it the way you see it here, right? I start off with the 8, x, right? Nothing really changes, and then the sign are opposite, right? Because this is a binomial, not a trinomial. Just like that, that's it, okay? So do me a favor, try these 3 right now, and then when you come back, I'll show you the answers, okay? So, yep, press pause right now. All right, and we're back, and these are my 3 answers, okay? So press pause if you want to, check your answers. Couple more things and then we're done, okay? All right, I'm feeling kind of bad that we're at 15 minutes already. All right, now let's see what I want to show you. Yeah, you can do that already. You can do that. Let's see. Yep, okay, so I want to try these 3, all right, and then we're done. Now, here it says factor completely, and there's a reason why it said that, all right? Because look, even if you see this and you say, Mr. Ng, like, I can't do this because like 3 is not a perfect square, neither is 27. Don't worry yet. You can't do this yet, all right? But what you could do is look. What's the greatest common factor between 3 and 27? Yeah, 3, right? Not only is it 3, it means you could actually factor that out first, right? So what I'm going to do is I'm going to rewrite that, right? It's 3. I'm going to factor out the 3, right? So that leaves this with x squared, and that's minus, right? 27 divided by 3 is 9, right? So I could check real quick, 3x squared, right? Here, I can do it like this, all right? 3x squared and negative 27, right? 3x squared minus 27. Now look at this. Can you factor this the way we've been doing just now? Yes, you can, right? Like this, right? So you got your difference of 2 squares again, like so. That's it, okay, right? Not bad, right? Now, knowing that, try it for these next 2, and then we're done for the day, okay? So when you come back, I'll go over it with you, okay? So press pause right now. Okay, real quick, all right? These, right? I'm looking at 18 and 50. I'm trying to think what are the factors between 18 and 50. Let's see, man. What about 3? No. 5? Nope. 6? Nope. 9? Nope. Okay, it's probably gonna be 2 then. All right, fine. All right, 2, right? So the inside is x squared. 9x squared actually, right? 2 times 9, right? 9x squared minus 25. Aha. 2, like that, right? How do I get this difference of squares? Well, they're both, these numbers, right? The 9 and 25 are both perfect squares, so I can, it's fairly safe for me to assume I can just use the same numbers, all right? So that would be 5 and 5. And then just positive and negative. Okay, all right? Totally doable, right? Now, this last one, same thing. So I factor out the 3, so that's a squared minus 1, all right? This one's even easier, all right? And then that's a plus 1, a minus 1. See, not too bad, right? Okay, so that's it, all right? I'm gonna sign off. Thanks for watching. Have a good day, and I will see you tomorrow, all right? Bye-bye.
OMG, that was so good.